Okay, so some of you wanted a little bit more assistance with the square root ones. So we'll start off with the basic one like this. F of x equals square root of 5x plus 1. Just remember there should be a little statement here where the thing underneath the square root has to be greater than or equal to 0. Because if that thing there is a negative, then it doesn't make sense. Anyway, let's get stuck into the calculus part of it. So we put our formula down and now we do our substitution as we have been able to do with ease wherever. So remember, f of x plus h, that means wherever x is here, replace it with x plus h. So I copy the square root, but this time instead of saying times 5 by x, we're replacing with the x plus h. Okay, and then we have to put the plus 1 minus our function, which is 5x plus 1, and that's all over h. Now go back to our game plan with first principles, and what we're trying to do is as soon as we can, we want to replace h with 0. Now we can't do it now because we would be dividing by 0, which makes it undefined. So we have to try and pull out a common factor of h on the top line. Now previously that was okay because when we expanded the top line or fiddled, we were able to quite easily pull out a common factor of h. It's a bit harder here when we've got square roots and we need to get rid of it. We can't square because then we get a whole lot of square roots in the middle. Okay, so if you have a think about it, if I have root x plus 1 squared, that's going to be root x plus 1 times root x plus 1. Root x times root x, I get the root x, which, oops, you don't get the root x. You get root x squared, which becomes x, right? So that times that. But then I get a root x times 1, so I get an extra root x. Then I get another root x here, and then I get the plus 1. So what we want to try and do is get rid of these middle terms, and hopefully you are then remembering, oh, if I change this to a minus, so we're doing a difference of 2 squares, what happens now is this little sucker here becomes a minus. That one too is now a minus, and what happens is they cancel and the square roots have disappeared. Okay, so here we had a plus, I'm going to times by a minus. That's called the conjugate of this. So this is a minus, which means I'm going to times by that whole thing but stick a plus in the middle. Okay, so let's do that and have a bit of flair. Yeah, we'll change colour. Let's see what that one looks like. So we're going to times that by the square root, I have to write small now so I don't run out of room, 5x plus h plus 1, oops, all square rooted there. Instead of saying minus root 5x plus 1, I'm going to times it by plus root 5x plus 1. And of course, what I do to the top, I have to do to the bottom. Okay, and now what we will be doing is we're going to be expanding. Now the denominator, that's always pretty simple. So it's just going to be this h times this whole thing at the bottom. So it looks like it's going to be crazy hard, but really you're just copying. So 5x plus h plus 1 plus root 5x plus 1. And now on the top, what you're going to be doing is you're going to be timesing this by this. Technically you're saying this times this, but you know it's going to cancel out with the negative of this one times this one. So we're going to have root all of this times root that. That means it's that thing squared, so the square roots cancel out, which means I'm left with 5x plus h plus 1. And then minus, so the middle terms will cancel, and then I've got this term times this term. So a positive times a negative is a minus, timesing. The roots will cancel again because you've got root 5x plus 1 times root 5x plus 1, which become 5x plus 1. And don't be sloppy, you must put your brackets around here because you're taking all of that. Okay? And hopefully you will know that you have done this right fingers crossed, if once we expand the top line, remember the test is that anything that doesn't have an H should disappear. Takes a while to copy out, doesn't it? Okay, let's have a look. So 5x doesn't have an H, and we've got a minus 5x. That's great. And we've got 1. Take 1. Life is looking good. Carry on. Oops, change that back. Although I don't mind that colour. Okay, so what's left on the top line is 5h all over h. Oh, rewrite this. Plus 1. Okay, so what's going on here? Finally, the h's cancel, and so now, once the h's have cancelled, it's now that you can actually replace the remaining h with 0. So on top we have 5. Downstairs I've got a root 5x plus 1 plus another root 5x plus 1, which means I've got 5 over 2 lots of root 5x plus 1. And that's that one done. Notice my writing has gotten bigger. Okay, I think we'll go on and we'll do the one from the textbook that I imagine is baffling some of you. Okay, so this is one from the textbook, and let's have a go. You could simplify first, but we're going to leave it like this. We're just going to substitute it in. So here we go. Remember this, wherever x is, we're going to replace it with x plus h. Feel free to pause the video and you have a go at it first, and then unpause and check that you got the same thing, rather than just reading what I'm doing and copying. Okay, so loving those limits. Okay, here, instead of writing x, I'm going to be writing x plus h, and instead of root x, it's root x plus h minus f of x, which is x root x all over h. Now it's the same plan that we talked about before, where we want to cancel out. We want to replace h with 0. In order to do that, we have to cancel out. Because we've got these square roots appearing here, really hard to work with, so we want to get rid of them. And the way to get rid of them is to times by the conjugate. Let's see how purple comes up over here. So I'm going to times by, that's going to be x plus h times root x plus h. Now instead of the minus, that's going to become plus x root x. And downstairs we have, again, copying looks really impressive to someone just having a look at your work. Okay, and again, what's going to be going on is you're going to be timesing all of this by this. Technically, you're timesing this by the second term here, but that will cancel out with the negative of this times that. So, good old difference of two squares in action, that's helping us an awful lot. Okay, now when we've got this times this, remember it's all one section, okay? That times that times that times that. We can times in any order, so it's x plus h times x plus h, which I hope you will agree with me is x plus h squared. And then I've got root x times root x, which is just, root x plus h times root x plus h, which is just x plus h. Minus times a positive is a minus. X times x is x squared. And root x times root x is x. And downstairs it's just h times that denominator there. So it's h times, okay, let's copy all of this again, x plus h. root x plus h plus x root x. Okay. Now if we notice the top line, we can see we've got x plus h squared times x plus h, which is x plus h cubed, and x squared times x is also x cubed. Okay, and now we've got that monstrosity of a denominator to rewrite. There we go. Okay, x plus h all cubed. Now if you remember from class, we talked about Pascal's, or reminded you about Pascal's triangle. So 1, 1, 1, 1, 2, 1. The next line is, you always start with the 1, 1 plus 2 is 3, 2 plus 1 is 3, and 1, and this allows us to expand something that's cubed. So x plus h cubed becomes 1, x cubed, h to the 0, and then this is the coefficient of your second term, so it becomes 3. The x loses a power, the h gains a power. And then again, x loses a power, h gains a power, and then it's 1 h cubed. And we've got the minus x cubed there, which we're reasonably happy about because that will cancel out with our other x cubed here as I rewrite this denominator. Okay, so let's have a look at what's happening. We've got our x cubed here. What happened there? So we've got our x cubed, which is cancelled out with this x cubed. And so now while I'm here, I can pull out my common factor. It's going a bit slow. Pull out my common factor of h on the top line. So that becomes 3x squared plus 3xh. If you can hear that whimpering, that's my dog in the background because it's her dinner time. Loose. Okay, plus h plus x root x, and we're nearly done. So now those h's will cancel. There we go. We can now make h equal to 0. So this term will disappear, this term will disappear. I'm left with 3x squared upstairs. This h and this one disappear, so I've got x root x plus another x root x. Okay, and this means it's 3x squared over 1x root x plus another x root x is 2x root x. And this is where you now have to remind yourself a little bit about your exponential rules, because x root x, that's basically x to the 1 times x to the half, and when I'm timesing by the same base I add the powers, so this becomes x to the 1.5, and therefore I'm left with x squared divided by x to the 1.5, and when I'm dividing by the same base I take the powers. So 2 take 1.5 is a half, which means that's x to the half, and we can write that as root x rather than x to the half. But if you write it as x to the half, that's fine as well. So that becomes, come on, back to my pen. So we end up with that, and that's the end. It's all she wrote. So with square roots, the key is, remember, difference of two squares. And yeah, that's probably a pretty hard one. The next one in the textbook is also a little bit tricky, only because I think you have to expand something like to the 4th or 5th. Again, use Pascal's, but if you're having trouble with that, I'd say don't worry, leave it, and we'll do that one together. Hope this helps.